Hello everyone and welcome back to Tesla Harmonics. Today we want to continue looking at Module 26301-23, Load Calculations, Branch and Feeder Circuits in the NCCER 11th edition. This will be Section 3.00, Commercial Loads. Example 1, Loads on Multi-Outlet Assemblies. A total of 40 foot of plug mold includes one single receptacle per lineal foot. The multi-outlet assembly is to be connected to a single 120 volt circuit. What is the minimum size 120 volt circuit that would safely supply this light duty multi-outlet assembly? Light duty is calculated at 180 VA per 5 foot. Obtain the total anticipated VA load. 40 foot divided by 5 foot equals 8. 8 times 180 VA equals 1440 VA. Determine the minimum circuit ampacity. 1440 VA divided by 120 volts equals 12 amps. The minimum circuit ampacity would be 15 amps since it is the first available rating above 12 amps. Example 2. The conditions listed for the previous example have changed due to a change order associated with the project. It is now necessary to feed this plug mold with 3 circuits. The reason for the change is that more tools will be plugged in and operating to increase production. This means that the assembly must now be able to power several loads simultaneously. How many 20 amp 120 volt circuits would be required to supply this heavy duty multi-outlet assembly? First, we would determine the VA capacity of one circuit. 20 amps times 120 volts equals 2400 VA. Heavy duty load is calculated at 180 VA per foot. Obtain the total VA load. 40 foot times 180 VA equals 7200 VA. Determine the number of circuits required. 7200 VA divided by 2400 VA would be 3 circuits. According to NEC Section 210.62, how many receptacles would be required for a show window area that measures 67 foot in length? Divide the length of the show window by 12 foot to determine the number of receptacles required. 67 foot divided by 12 foot equals 5.58 receptacles. You must always round up in this case rather than round down to ensure that you have enough receptacles. Using NEC Section 220.14i, what is the total load for the receptacles required from the previous example? Multiply the number of receptacles by 180 VA per receptacle. 6 receptacles times 180 VA equals 1080 VA. Because the load is continuous, we would find 125% of the result. 1080 VA times 1.25 is 1350 VA. We would divide by voltage to determine the ampacity of the circuit. 1350 VA divided by 120 volts equals 11.25 amps. Applying the NEC Section 220.14G2, what is the load for a 30-foot long show window? We would multiply the total length of the show window area by 200 VA. 30 foot times 200 VA equals 6000 VA. Because the load is continuous, we would find 125% of the result. 6000 times 1.25 equals 7500 VA. Divide by voltage to determine the ampacity of the circuit. 7500 VA divided by 120 volts equals 62.5 amps. Sine loads, example 1. What is the maximum continuous load in VA that may be connected to a 20 amp 120 volt sine circuit? Determine the total VA for the circuit. 20 amps times 120 volts equals 2400 VA. Determine the maximum continuous VA load. 2400 VA times 0.8 equals 1920 VA. Loads for heavy-duty lamp holder outlets. Per NEC Section 220.14e, outlets for heavy-duty lamp holders are calculated at a minimum of 600 VA each. Example, a non-continuous load consisting of 4 120 volt outlets for heavy-duty lamp holders could be connected to a 20 amp branch circuit. 20 amps times 120 volts equals 2400 VA. 2400 VA divided by 600 VA per outlet equals 4 outlets. Commercial kitchen equipment loads. Example 1. What is the current load for one dishwasher booster heater? The booster heater has a nameplate rating of 15 kW, 208 volts at 3 phase. We would convert the nameplate power rating in kW to VA. 15 kW times 1000 equals 15,000 VA. Determine the current load by dividing the product of the voltage and the square root of 3. Current load equals 15,000 VA divided by 208 volts times 1.732, or 15,000 VA divided by 360.256 volts, and the current load would be 41.64 amps. What is the demand load for 6 units of commercial kitchen equipment with a total VA rating of 47,000 VA? We would use NEC Table 220.56 to determine the demand factor. We multiply the total VA rating by the demand factor. 47,000 VA times 0.65 demand factor equals 30,550 VA. According to the NEC, what is the motor full load current for a single phase 2 horsepower 230 volt motor? Using NEC table 430.248 to determine the full load current for single phase AC motors. A 2 horsepower 230 volt motor has a full load current of 12 amps. What is the motor full load current for a 10 horsepower 460 volt 3-phase motor? Using NEC table 430.250, we would determine the full load current for a 3-phase AC motor. A 10 horsepower 460 volt 3-phase motor has a full load current of 14 amps. What size copper THWN branch circuit conductor would be required to power a 25 horsepower 460 volt 3-phase motor? We would use NEC table 430.250 to determine the minimum ampacity by increasing the full load current value by 125%. 34 amps times 1.25 equals 42.5 amps. Using NEC table 310.16, we can determine the branch circuit conductor size. Number 6 THWN copper is listed at 55 amps using the 60 degree C or 140 degree Fahrenheit column. What size dual element time delay fuses would be required for a 50 horsepower 3-phase squirrel cage motor operating at 460 volts and stamped with the NEMA design letter D? We would use NEC table 430.250 and then NEC table 430.52C1 to determine the full load current and proper percentage to multiply by. 65 amps times 1.75 equals 113.75 amps. Per NEC section 430.52C1A, the next higher standard fuse is 125 amps. What size inverse time circuit breakers will be required for a 10 horsepower 3-phase squirrel cage motor operating at 208 volts with a NEMA design letter B? We would use NEC table 430.250 and then NEC table 430.52C1 to determine the full load current and proper percentage to multiply by. 30.8 amps times 2.5 equals 77 amps. The next higher circuit breaker rating is 80 amps and NEC section 430.52C1B3 would permit a 110 amp circuit breaker if the 80 amp breaker is inadequate for the starting load. Welding machine loads. What size THWN copper branch circuit conductors would be required to supply an arc welding machine with a non-motor generator and a nameplate current of 70 amps with a duty cycle of 80%? We've used NEC table 630.11a. 70 amps times 0.89 equals 62.3 amps. Use NEC table 310.16 to determine the branch circuit conductor size. Number 4 THWN with a rating of 70 amps is required using the 60 degree C or 140 degree F column. What size THWN copper branch circuit conductors and circuit breaker would be required to power a resistance welding machine with a nameplate current of 125 amps and a duty cycle of 40%? We've used NEC table 630.31a. 125 amps times 0.63 equals 78.75 amps. Then we would use NEC table 310.16 to determine the branch circuit conductor size. Number 3 THWN conductors with a capacity of 85 amps. Per NEC section 630.32a, multiply by 300% to size the overcurrent protection device. 125 amps times 3 equals 375 amps. Per NEC section 630.32, the next higher standard size listed in NEC section 240.6a is used, which would be a 400 amp. Here's a trade term you should read over and become familiar with for this session, and some review questions for this session. The load for 8 foot of a multi-outlet assembly with the capability of powering all the receptacles simultaneously is 720 VA, 1440 VA, 2160 VA, or 2880 VA. And that's going to be B, 1440 VA. How many receptacles are required for 60 foot of show window length? Will it be 3 receptacles, 5 receptacles, 6 receptacles, or 8 receptacles? That's going to be B, 5 receptacles. What is the maximum continuous load in VA that may be connected to a 20 amp 120 volt sine circuit? Is that 1680 VA, 1920 VA, 2700 VA, or 2880 VA? That's going to be B, 1920 VA. Per NEC Section 220.14E, outlets for heavy-duty lamp holders are each calculated at a minimum of 180 VA, 240 VA, 480 VA, or 600 VA. That's going to be D, 600 VA. What is the calculated demand load for 4 pieces of commercial kitchen equipment with a total VA rating of 36,000 VA? Would that be A, 23,400 VA, B, 28,800 VA, C, 36,000 VA, or D, 45,000 VA? And that's going to be B, 28,800 VA. What is the motor full load current for a single phase 5 horsepower 208 volt motor? Is it 19.6 amps, 30.8 amps, 46 amps, or 57.5 amps? That's going to be B, 30.8 amps. What size copper branch circuit conductors would be required to supply a non-motor generator arc welding machine with a nameplate current of 100 amps and a duty cycle of 50%? Would that be number 3 AWG, number 4 AWG, number 6 AWG, or number 8 AWG? That's going to be A, number 3 AWG. All right, everyone, that was it for that session. Next session will be review for the module testing. We'll do that in the classroom, and I will see you over there.